So in this video, we'll cover a few different important terms and concepts, including percent yield, theoretical yield, and actual yield. And then we'll finish by doing a practice problem. Okay, so let's start by defining what percent yield even is. Think of percent yield as a measure of the efficiency of a reaction. So in other words, it's how well a reaction can form products given a fixed number of reactants. Now there's an equation you can use to solve for efficiency or percent yield, and that's equal to the ratio of actual yield over theoretical yield multiplied by 100. So let's define what actual yield and theoretical yield are. So theoretical yield is the theoretical maximum amount of product you can make. Now, in actual circumstances, this is very hard to reach because there's always going to be side reactions. Not all the reactants are going to react properly. This is a value that is determined based on the limiting reagent, right? As we mentioned in the last video, limiting reagent is what determines how much product you can make, and the limiting reagent is what determines theoretical yield. Now, very important to remember that the theoretical yield is something that is always calculated. Okay, so this is something that you always need to calculate. It's never given. So I'll write calculated by you, given the information in the problem and based on the limiting reagent. The actual yield is something that needs to be experimentally determined. And this is the actual amount of product created from a reaction. And as you probably might have guessed, it's always going to be lower than your theoretical maximum. Okay, and so as I mentioned before, this value will always be given to you in the problem, right? Because it's not something you can determine based on the reaction. It's something you have to determine experimentally. Okay, so here are some strategies. Here are a few tips when you're solving percent yield problems. So the first is you always need to calculate the theoretical yield because that's not given to you. And you use the limiting reagent, again, to solve for that. Then once you know the actual yield, which is going to be given to you, you divide actual yield by theoretical yield and then multiply by 100 to calculate percent yield. So let's do that. Let's do those steps for a practice problem. So the question says the following. Consider the following reaction. SiO2 plus C makes SiC plus CO. Suppose that 10 grams of SiO2 reacts with 8 grams of carbon, forming 5.14 grams of SiC. Determine the limiting reagent, right, from these two reactants, okay? So the first thing you should always do when you see a chemical reaction is to balance it. So let's balance this guy. So we know that we have one Si on the left, one Si on the right, so we don't have to do anything there. But we have a problem for oxygens, right? Because I have 2 on the left and only 1 on the right. So what I'm going to do there is put a 2 there. And so now with our oxygens balanced, I need to make sure that my carbons are balanced. So I have 3 carbons on the right and only 1 on the left. So I'm going to put a 3 in front of this guy. And here we should have a fully balanced reaction where we have 1 Si on each side, 3 carbons on each side, and 2 oxygens. So now we can go ahead and determine the limiting reagent. And remember that the steps for determining the limiting reagent is always to convert from grams to moles. So we're going to start with 10 grams of SiO2, and we're going to convert that to moles using molar mass. And so we know that for every 1 mole of SiO2, I have 60.084 grams SiO2. And then when you put that in your calculator, you should get 0.166 moles. Okay, so let's do the same thing for carbon, right? I have 8 grams of carbon. I know the molar mass. Carbon is 12.001 or 011 grams of carbon per 1 mole. I put this in my calculator and I get 0.666 moles of carbon. Okay, so now from these numbers, we can figure out which one's the limiting reagent. Now we have one extra step here because the molar coefficients between carbon and SiO2 are not 1-to-1 as they were in the previous video. Now they're 1-to-3. So there's just one extra step. You just have to figure out, well, if I have 0.66 moles of carbon, how many moles will that react? How many moles of SiO2 will react exactly with 0.66 moles of carbon, right? We know that for every 3 moles of carbon, you react with 1 mole of SiO2. So this guy, so that ratio is basically 1 to 3, right? So if I have 0.666 moles of carbon, that's going to react with 1/3 times of SiO2. So if I take 1/3 of 0.666, I get 0.2. So I can say this reacts exactly with 0.222 moles of SiO2. Okay, and how I figured that out was just molar ratios. So theoretically, this could react with 0.22 moles of SiO2, but I only have 0.166 moles, right? So in order to figure out which one's the limiting reagent, I just compare these two numbers, right? And here I only have 0.166 moles of SiO2, so this guy is going to be the limiting reagent. SiO2 is the limiting reagent. And that's what's going to determine the rest of our calculations. So SiO2 is our answer. Okay, and we know that we have 0.166 moles. Okay, so let's move to the next part. So the next part asks us to calculate the theoretical yield of SiC, right? And as I mentioned before, you always use the number of moles of limiting reagent to calculate product yield. So we're going to start with the number of moles of our limiting reagent, which was 0.166 moles of SiO2. And remember, in order to convert from the units of one element to another, you're always going to use molar ratios. So essentially, for every 1 mole of SiO2, I form 1 mole of SiC. So now I've converted my units from moles of SiO2 to moles of SiC, and now I go from moles to grams using molar mass. So for every 1 mole of SiC, that's equal to 40.097 grams of SiC. And then we put that all in our calculator, and we should get 6.66 grams. So that's our theoretical yield, our theoretical maximum, giving our starting amount of reactants. Okay, and then the last step, as you probably guessed, is to calculate the percent yield for SiC, right? We already know the theoretical yield, which we just calculated, and this number right here represents the actual yield, right? How much was actually formed. So what we're going to do is divide actual yields by theoretical yield. So we're going to take actual over theoretical. So that's equal to 5.14, all divided by 6.66, which is what we found out in the previous problem. Multiply that by 100, and you should get an efficiency or percent yield of about 77%.